so today we're doing 1.3, and you might like it because it's a break from the graphing. I know graphing feels like a lot of work. We're going to be doing a lot of algebra today, and we're calling some of the function notations from algebra, and we're going to use that to transform linear functions. So by the end of today, you'll be able to transform the linear functions and solve problems using the linear transformations. We will be performing multiple transformations on a function as well. So we're going to go over a few rules. The first one is when you have a horizontal shift of h units. So a horizontal shift is just another way to say translation. Okay, so shift and translation are interchangeable. And then here's our rule. If f of x goes to f of x minus h, and then the h value, if it is positive, that means you're going to the right. Or if they tell you you're going to the right, the h value is positive. But when you plug in something positive to an equation that is already f of x minus h, remember that that minus also acts as what? What does the minus mean besides subtraction? Okay, yeah, negative, what else? Oh, yes, in this case it'll be left. Looking for something that starts with an O. Opposite, it's the opposite. And the reason why I want you to think of it like that is because if it is right and if it's positive, when you plug in a positive number for h, let's practice. Let's say you're going 5 units right. If you're going 5 units to the right, h would be 5. If I plug it into this equation, it's x minus the 5. See how you have the minus in front? Because if you subtract something that's positive, it's just subtraction. But if you were going to the left, h would be negative 5. And if I do x minus negative 5, what happens when you have minus the negative? Yeah, it becomes positive. So really, when you're looking at that rule, you need to think of it as the opposite. If you're going to the right, you're going to see x minus 5. If you're going to the left, you're going to be seeing an x minus h, and that's all because of our original rule. Okay? And that's what you guys have written down over here, is what I just modeled for you with the 5. Now, the vertical shift, notice where the value is on that. The vertical shift, again, same as the translation, but we're using k units. You're either going to go up or down. So if k is positive, you're moving up. If k is negative, you're moving down. Now, look here. You have the plus k here. Okay, so if it's a positive value, you will have plus 5. If you're going down, it will be minus 5. Okay, so it will be minus, plus that value, minus that value. All right, so now we're going to move on to reflections. So the 2 reflections we're going to look at is across the y-axis and across the x-axis. All right, so if you are going across the y-axis, I want you to take notice of where that negative falls. It's going to be inside of the parentheses, okay? And then if it's across the x-axis, it's going to be outside of the function. Now, the reason why this is because when you have a reflection across the y, do you guys remember what it affects? Does it affect the x or the y? The x. So see how the negative goes directly on the x? That's what it's affecting. If it's on the outside, it's going to be affecting the y, which is what happens there. Now, I like to come up with little ways to remember things. So for me, I think of, for the x, did you guys ever have people who like would sign their notes XOXO? Hugs and kisses? That's how my mom and dad would sign their notes to me. Have a great day, XOXO, mumsy. So I remember XO means X is on the outside. Sometimes I'll do that, XOXO. Okay, if that's too mushy for you, you're like, no, I'm not going to do that. I have another one. Okay, so for Y, Y is on the inside, right? Y and I, they rhyme. So Y-I. Y and O don't rhyme, so Y is on the inside. Okay, so that might help you remember as well. Okay, so we are going to apply these using example 1. And then if you want to have out your highlighters, I will be highlighting a lot today. If you want to borrow a highlighter, I do have some extras. I'll put them in the back there so you guys can grab them. Alright, so let's read through the directions here. It says, let g of x be the indicated transformation of f of x. So g of x and f of x, that is just function notation. And then what it's telling us to do is write the rule for g of x. Those are the same exact instructions that are going to be on your practice assignments, on your quizzes. So we want to make sure that we understand what that means when it says write the rule. That means that you're writing the equation or the function. And we will be using function notation. Okay, so before we get started, I'm actually going to remind you a few things about function notation. In A, you can see f of x equals x minus 2, right? So if I told you that f of x, you don't have to write this part down, you can just listen to this part. If f of x was equal to x minus 2, and I asked you to find f of 4, would you guys know how to do that? It's okay if you don't know. Can you tell me what you would do? Yeah, you get it?
I would put 4 for x.
Good. Okay, so she said she put 4 in for x. So see how this was f of x, now it's f of 4? All you have to do is plug in 4 where the x is, so just 4 minus 2, which would be 2. Okay, let's say f of x was something different. Let's say f of x was x squared plus 1. And I asked you to find f of negative 1. So how would I do that? What would I have to do with the negative 1? Yeah, plug it in for x. So negative 1 squared plus 1, and what would that be? 2. Negative 1 squared is 1. Okay, so that would be 2. Alright, so now are we feeling better about that function notation? If you have f of a number, you plug it in. Thumbs up if you're feeling good. Awesome. Good, because we are going to be plugging things in for this. It's just going to be a little bit different. So I hole punched these for you guys, so it cut off some of my stuff. So we're going to put that back on there. This is a horizontal transformation that's going right 3 units. You're going to notice I'm going to do a lot of annotating today. So So f of x is x minus 2. I'm actually going to highlight that. That's our function. Now, we just talked about when you're going right 3 units, that means your h value is positive. So your h value is 3. Okay, if you're going right, it means that it's positive. The rule is f of x minus 3. Right? F of x goes to f of x minus 3 because you're plugging it in to x minus h. Okay, so the rule is f of x minus h, so f of x minus 3. What questions do we have about this rule, or the h value, or why it looks the way it does? Remember, if you're going right, you're going to see the opposite. All right, then we are going to create g of x. So g of x is going to be f of x minus 3. That's our rule. So before, you guys were just telling me, oh, if I have f of 4, I plug in 4 for x. If I have f of negative 1, I plug in negative 1 for x. Well, now I have an expression. So instead of x, I'm going to be plugging in x minus 3. So to do that successfully, this is the strategy I use. I look at my equation, which is x minus 2, and instead of x minus 2, I put parentheses minus 2. So my function is x minus 2. But I know I'm going to have to substitute something in for x, and that's the x minus 3. So I just go ahead and do that substitution. Now, in some cases, you might have a coefficient here, and you have to distribute, but I don't have a coefficient on the parenthesis, so this is the same thing as x minus 3 minus 2. I can combine my like terms, which would become x minus 5. Okay, and then so g of x equals x minus 5, that's going to be my rule. So essentially, what we're doing here is you're going to plug in x minus 3 for x. Okay, that's what we did. I put that in quotes. I put for x in f of x. I know that's kind of wordy. Okay, so you're plugging in the x minus 3 for x in f of x. Yeah.
Why don't you change the f of x to g of x?
So in the directions it said let g of x be the transformation. So f of x is our original. G of x is going to be f of x translated 3 units right. So that's our new function. So this is our original, this is our translation. And then if you guys wanted to double check and make sure that you did that correctly, do you guys think that you would know how to do that on your graphing calculator? So remember our y equals from yesterday? See how you have a bunch of them? That means that you can plug in multiple ones on your equation. And really, this is the only thing we'll do with the calculator today is to check it, so don't stress out if you don't have yours. So if your original is x minus 2, and then your new graph is x minus 5, you can plug those in, hit graph, and then I would just compare that it went 3 units to the right. If you have some of the newer ones, like the flatter ones, what's really cool about what you guys see? Yeah. Yeah, they do. They have different colors, so it's easier to see. And I do like those. So you could just find a point here and look, 1, 2, 3, 1 over 3. And then you know that you have the correct equation. Okay? You don't have to check that. I'm just showing you a way that this could be useful. Okay? All right. Let's look at B. So B is a little bit different. Instead of them giving us a linear function, it's the linear function defined in the table. So the linear function defined in the table. And then we have to perform the reflection across the x-axis. Okay, so in order to perform the reflection, we have to know what the linear function is, and we can make the linear function ourselves just from this table. Because remember, the linear function, the standard form is slope-intercept form. Do you guys remember what that is? Slope-intercept form is y equals mx plus b. So what we're going to do is we're going to use this table to write the equation. And that's what I wrote down for step 1. Write the equation of f of x in slope-intercept form. So for slope-intercept form, all we need is the slope and the y-intercept. Okay? Do we know any of those right away from looking at the table? Yeah, well, which one do we know? We know what? What intercept do we know? Yeah, Deshaun? Yeah, how did you find it? Yes, okay, so for every single y-intercept, what is the x-coordinate? 0, right? It's always like 0, 1, 0, 3, 0, negative 5. So if you have a 0 in your chart, you are lucky because that is going to be your y-intercept. Okay, so I'm just going to box this in. Okay, this tells you the y-intercept. The whole box, not just the 0. Okay, so we would say that the y-intercept is what? Yes. Okay, the y-intercept is 0, 1. And so when y equals mx plus b, what am I going to plug in? Yep, the b is going to be what? What does b equal? 1. Okay, so the x value is 0, so we know that it's 1. I'm also going to tell you how you can find it if you don't realize that from the chart, or maybe some of your tables, maybe they don't have the y-intercept in there, you have to find it. It's also something that you have on your algebra review packet. Okay, so now I have to find the slope. I have a table. Tables are just a collection of points, right? So if I have all these points, how can I find my slope? Yeah, so most of you guys know slope is rise over run, but remember the equation when you have 2 points, m is going to equal y2 minus y1 over x2 minus x1. Okay, so use that to find the slope. And when you're doing that, it doesn't matter what 2 points you choose. I always just choose the first 2 that are in there. So I look at my table and I say, okay, this is negative 2, 0, and this is 0, 1. But it doesn't matter. You choose any 2 points from the table. Okay, any 2 points. x1, y1, x2, y2, and then will you guys find the slope for me? And then once you've done that, see if you can write the equation in slope-intercept form. So find the slope. How are we feeling? What was our slope? What did you guys get? 1/2. Okay, so 1 minus 0 over, and then this was 0 minus -2, so it became plus 2, so it should be positive 1/2. So remember, you're writing the equation in slope-intercept form. We're going to use f of x. So 1/2 x, and then we already found that b was 1, so it'll be plus 1. Okay, so there you go. Now, if you don't have the y-intercept in the table, okay, you can solve for b using the slope and a point. And it can be any point on the table. I'm going to show you how to do it, but you don't have to write it down. I'm just going to show you how. So let's say in our table we didn't have the y-intercept, okay? Then I would take my slope, which is 1, 2, and I would pick any point on my table. I'm going to choose 2, 2, because we haven't done much with that guy yet. Remember, every point is an x and a y. So this is something that you had on your algebra review packet. So if it's y equals mx plus b, I'm just going to plug 2 in for y, 1/2 in for m, 2 in for x, plus b. What's half of 2?
1.
Okay, and then subtract 1 from both sides, and then you'd find your y-intercept. Okay, so in this case, obviously it was 1, because we already had that on there, but you could use that. Okay, so that's something that you did in Algebra 1, and maybe even in geometry a little bit, because we dealt with parallel lines and all that good stuff. All right, so for step 2, now we're going to write the rule for g of x. So this one had a little more work because we weren't just given the equation, we had to solve to find it. So for writing the rule for g of x, okay, writing the rule for g of x, we have to remember that this was a reflection across the x-axis. So for a reflection across the x-axis, let's think of what our rule is, right? XO, XO, so the negative goes on the outside. All right, so when we're writing the rule for g of x, g of x is going to equal negative, and then all we have to do is plug in f of x. So again, whenever I substitute something into the equation, I'm going to put my parentheses. That way I don't forget to distribute if I need to. So f of x, what we found here, was 1/2 x plus 1. Okay, so we're substituting what we found in step 1, and then we're going to simplify. So now I do have something on the outside of the parentheses that I have to distribute. So g of x is going to equal negative 1/2 x minus 1. And this is our final answer. Negative 1/2 x minus 1. Okay, what questions do you have for me on that one? We'll do more practice too with the substitution as we get to the back. All right, so we're going to do stretches and compressions. So we're going to talk about horizontal stretches and compressions, and then vertical stretches and compressions. All right, so the horizontal stretch or compression has the same rule. And this is by a factor of B. So for the horizontal stretch and compression, the factor is going to be B, and you start with f of x, and it becomes f of 1 over b x. So f of 1 over b x. Okay, now the stretch or compression, that just means if it's a stretch, okay, your b value, the absolute value of that is greater than 1, and it's a compression if it's between 0 and 1. And they use the absolute value because it's always going to be positive. In fact, that negative in front would indicate what type of transformation. Negatives are going to indicate what type of transformation. If it's on the inside, it would. Remember we just talked about if there's a negative outside or a negative inside, those represent the reflections. Okay, so if you have a negative there, it would be a reflection. For linear, it just depends on what it is. And then the compression has to be between 0 and 1. Now we're going to talk about this 1 over b. 1 over b. Okay? When you put 1 over a number, do you guys know the relationship between b and 1 over b? You guys know what those would be called? Yes, good. It's the reciprocal. So, when you are doing this, you are going to always use the reciprocal of b. Okay? And if you had something, let's say b was 2/3, right? If b is 2/3, when you plug it in, you're going to do the reciprocal. If you wrote it as 1 over 2/3, right, we don't want to keep a number like that. We don't want to keep it as 1 over 2/3. Remember, this is the same thing as 1 divided by 2/3. So you skip, you flip, you multiply. So this would be what you plug into your function. It would be the 3 over 2. And we'll practice that on the next example. All right, and then the other type is vertical. So you could have a vertical stretch or compression. And if it's vertical, they use a factor of A. And f of x is going to go to A times f of x. Okay, so it's the same thing. For a stretch, you're looking at a value that's greater than 1. A compression is going to be a value between 0 and 1 when you take the absolute value. Let's think about why you don't have the equal sign there. What would happen if you had a factor of 0? If you multiplied everything by 0, what would happen? You would just get 0, and that would completely change the value of the function, right? It would just be 0. And then if you multiply by 1, when you multiply something by 1, what do you get? That number, right? So it would just be the same. Okay, so it wouldn't change that. All right, and then the factor of A is going to be on the outside. So if it's horizontal, it's inside, it's directly on the X. Horizontal affects the X. And then here, the A is on the outside because it's going to be affecting your Y. All right, so let's turn it over. And we're going to start applying these rules. Do you need any more time with this part? All right, so it says let g of x be, and then we're going to do several examples. So for the first one, it is a horizontal compression. And then they would fill this part in with you. We're going to fill it in together. F of x equals negative x plus 4 by a factor of, by a factor of 1/2. And then we are going to write the rule for g of x. So again, that rule is going to be the equation. I just put EQ in. Alright, so the first thing I want you to do is I want you to write the rule. So if it's a horizontal compression, we're going to write the rule for that. So it's going to be f of x becomes f of 1 over b of x. So remember, we talked about 1 over b is the same thing as the reciprocal. Okay, so according to this, your b value is 1/2. If b equals 1/2, the reciprocal of 1/2 is what? 2. Okay, so this is going to be g of x equals f of 2x. Now, if you feel like you're not going to remember why you put in 2, you can definitely add this step where it's the f of 1 divided by 1/2, right? But 1 divided by 1/2 is 1 times 2 over 1, which is 2. Okay, so that's why I'm just jumping right here. Yeah, once I know the reciprocal, that's what I'm going to be plugging in. Alright, well now that I have f of 2x, I just have to substitute that in to my equation. So that's similar to what we were doing on the front side. Okay, so f of x is is negative x plus 4. So remember, I like to put the parentheses in place of x. So negative and then parentheses plus 4. And that way I remember I just have to substitute. And I'm not going to distribute, I'm just going to multiply. This is like a negative 1, and this is one term. So negative 1 times 2x is negative 2x plus 4. I can't simplify it any further, so this is my final answer. You guys have no questions that you have for me for that one?
Where did you get the plus 4 from?
So that is in the original function. So because this is negative x plus 4, right here, this one here. So this will be given to you. So I have this exact equation, the negative x plus 4. It's just instead of an x, I have to replace it with 2x.
Okay. So like, is that just like the normal problem you just filled it in?
Yes. Yeah. So for this one, we're going to be doing a vertical stretch of, and for this one, we're going to use f of x equals 3x plus 2. So I just wanted to give you guys a variety of different equations. And that's by a factor of 4. And then again, we're writing that rule for g of x. Alright, so I want you guys to try this one. Start by writing the rule. So I just want to clarify because a couple people were asking me about this. This is something that's going to be given to you. Your AFFX will be given to you. Okay, so I just leave those blanks so that you guys can fill them in with me and make sure that you're staying along with me. So the AFFX is something that will be provided to you in the problem. And then for the vertical stretch, the first thing we want to do is just write down the rule. So that is f of x. F of x goes to a times f of x. Okay, so that was, at the very least I wanted you to do that. And then the factor is 4. So that means that your a value is equal to 4. Okay, so for your g of x equals 4 times f of x. Now this is a little bit different from the last one because that 4 is on the outside. So when you do the substitution, it's 4 times your equation, which is f of x. So this is 4 times 3x plus 2. And then you do have to distribute the 4 to both parts. And your final equation should have your g of x equals in it. So you are going to distribute 4 times 3x is 12x, 4 times 2 is 8, and then this will be your final answer. Okay, thumbs up if you're feeling good about that. All right, so now we're going to combine them. We're going to do 2 transformations to one equation. And then all we have to do is perform these in order. So for example 3, we are going to let g of x be a horizontal shift. So we have a horizontal shift of, and again this will be provided to you, that f of x equals 3x. You're going to be shifting that left 6 units, but now it's followed by a horizontal stretch by a factor of 4, and we're still writing the rule. Okay, so first is what I highlighted in pink, second is the green, this is my direction. So for step 1 is going to be exactly like what we were just doing, okay? So it's a horizontal shift, left 6 units. If you are going left, okay, remember the rule is f of x goes to f of x minus h, but our h value is negative 6. Why is it negative? Because you're, yes, okay, so you're going to the left, that's what makes it negative. So when you plug that in, it's going to be f of x plus 6. And again, that's because you're doing x minus negative 6, which becomes plus a positive. Minus the negative is becoming the plus. Okay, so now let's do this step. So f of x plus 6, I'm going to look at my f of x. It's 3x. So I put the parentheses. And then I know I can just substitute in my x plus 6. So now I'm going to distribute. 3 times x is 3x. 3 times 6 is 18. That's what I have for step 1. Okay, so this is my new equation. And then I'm going to use this for step 2. So step 2, we are going to do the horizontal stretch by a factor of 4. So the horizontal stretch is f of x goes to f of 1 over b of x. We remember that that's the reciprocal. And this is a whole number, so when it's a whole number, it's a little bit easier, because if you just plug in b, it's 1 over 4x. You don't really have to think about flipping it. You can just substitute it in for b. So now we're using this equation. So you're not using the original f of x, okay? You're using this equation that you got here. So this is going to be 3x plus 18. So we're using that for this step. But instead of x, we have 1/4 x. See if we can simplify that. So think about what your rule is when you are multiplying fractions. All right, do you guys remember the rule? You multiply the whole number by what part of the fraction? Top or the bottom? No. Remember, you can think of this like 3 over 1. You got to multiply the whole number by the top. So 3 times 1 is 3. 1 times 4 is 4. So it's 3/4 x plus 18. Okay, so if you need to put that 1 underneath, okay, so you always multiply the whole number by the top. You can think of it as 3 over 1. And this is your g of x. So whatever you get in step 1, you use that equation as f of x for step 2. All right, you guys want to try the last one without me at first? Okay, so you have a vertical compression, and this one I gave you the equation. So it's f of x equals x. This is how it will look in your book. I didn't mean to rhyme, but I did. So a factor of 1/2, and then you have a horizontal shift, 8 units left. And I want you to write that rule. All right, let's see how first step went. So you had a vertical compression by a factor of 1/2. So if it's vertical, a times f of x which is going to be 1/2 times f of x. Okay, how are we doing that, identifying the rules? We can look back, we can find those, we can plug in the factor. Okay, so then from there you just have to decide, am I plugging in the whole equation or am I plugging something in for x? And if you see the f of x, you're going to be plugging in that whole equation, which in this case is just x, right? So you're just substituting in, if it's f of x equals x, you just have x here. So this is 1/2 x. That's what we found in step 1. So that's what we're going to use when we go to step 2. So for step 2, it's a horizontal shift, 8 units left. So remember, that's where your h is -8. So this is f of x. And I'm fine if you just skip to this rule. As you practice, you're going to know right away, oh yeah, if it's negative, that means it's going to be opposite. It's the plus, because you're going to the left. Okay, so then your g of x is 1/2 times x. Okay, so you're using this. Uses f of x in step 2. Okay, and then you're going to plug in your x plus 8. And then distribute. So you have 1/2 x plus 4. You distribute because you have your 2 terms. And that's your final answer. Okay, so I definitely recommend doing the practice for this. It's something where there's a bunch of different scenarios. Okay, and then I'm also going to post the keys to homework 1.1 and 1.2, so you can check those and come in with questions, and we'll talk about that next week, okay? All right, have a good weekend. Have some fun.